Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to anticipate the magnitude of the standard error of a sampling distribution of sample means. We will use the estimating elapsed time data to talk about this learning goal. When we simulate many values of the sample mean under the null hypothesis, in this case that the average estimated time is 10, you see a familiar bell-shaped curve. Notice that the standard deviation of the sample means is 0.926. So a reasonable question is, could we have predicted that? The answer is yes, and that's exactly what theory-based approaches for one mean are going to do. The predicted value of the sample mean is given by the equation s over the square root of n. In this case, s is the sample standard deviation, that's 6.5 seconds. The sample size is 48, giving us a theory-based prediction for the standard deviation of sample means of 0.938. Notice that that's very similar to the standard deviation we got when we simulated a 0.926. They're not exactly the same because the simulation will always be a little bit different than your theory-based, because every time we simulate we get a different set of simulated statistics. Couple quick words of caution. First, that predicted value, in this case 0.938 for the standard deviation of the sample means, is only accurate if validity conditions are met. In this case, the validity conditions are that the underlying data is symmetric, or, as is the case here, the sample size is greater than 20 and the data is not strongly skewed. We have some right skewness in this data set, but the sample size is large enough and it's not a real strong skewness. Secondly, as we mentioned a moment ago, the predicted value won't match exactly what you get when you simulate because each set of simulations is a little bit different.